Verify ready for launch. FTS.
FTS go. Prop
Go. ABI.
ABI's go.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
Welcome to the NROL-172 launch. The Falcon 9 rocket is currently awaiting liftoff from Space Launch Complex 4 East at Vandenberg Space Force Base at 7:13 p.m. Pacific Time. My name is Tucker Spencer Wallace, and I'm a senior Starlink engineer here at SpaceX. For this mission, we are taking NROL-172 to orbit on behalf of the National Reconnaissance Office, or NRO. Today's mission is the 13th launch of the NRO's proliferated architecture and the second with Space Systems Command under the National Security Space Launch Phase 3 Lane 1 program. This will be the 9th flight for today's Falcon 9 booster after previously launching Sentinel-6B, Twilight, and 6 Starlink missions. The range is green and we are on track for an on-time liftoff at 7:13 p.m. Pacific Time. If, for any reason, we are unable to launch today, a backup opportunity is available tomorrow at 3:15 p.m. Pacific Time. At the request of our customer, we will not be showing any views of Stage 2 or payload deployment tonight. But for now, the weather is green with a 0% possibility of launch weather constraints. The 229-foot tall Falcon 9 rocket supporting today's mission is a 2-stage rocket designed for the reliable and safe transportation of satellites, cargo, and people. At the top of the rocket is the payload fairing, a protective shell housing the payload, shielding it from the aerodynamic heating until the vehicle is outside the Earth's atmosphere. The shape of the fairing contributes to Falcon 9's overall efficiency, helping to reduce drag during the rocket's ascent. Once in space, the two fairing halves will separate and fall back to Earth, where they will be recovered for refurbishment and reuse on future flights. Right below the fairing is Falcon 9's second stage, which contains a single Merlin engine, or MVAC, equipped with a larger engine nozzle optimized for operating in the vacuum of space. Below the second stage is a black carbon fiber inner stage, which houses the MVAC engine until stage separation. Below that, we have the first stage, or booster, that is fully loaded with roughly 1 million pounds of liquid oxygen and RP-1 rocket-grade kerosene. The first stage makes up the bottom 2/3 of the vehicle and has 9 Merlin 1D engines at the bottom, which generate more than 1.7 million pounds of thrust. As mentioned, the first stage supporting today's mission will be making its 9th flight today. About 2.5 minutes into flight, the first and second stages will separate, and the booster will make its way back to Earth to land on our drone ship, Of Course I Still Love You, which is currently stationed in the Pacific Ocean. At T-minus 4 minutes and 40 seconds, weather continues to look favorable and teams are tracking no issues. Next up in the countdown, the Transporter Erector, or TE, will begin to retract away from Falcon 9. First, we'll see the clamps around the second stage open. As you just heard, that strong back retract has started, which means the clamp arms are beginning to open around the second stage. The clamps help stabilize the second stage during fueling and prevent movement in high winds. Once they're open, the rocket will be fully free at the top, but will still be held down at the base. You may hear the TE called the strongback, though the strongback is just one of the components of the Transporter Erector. The Transporter Erector has two components, a strongback alongside Falcon 9 and a launch mount underneath. The launch mount has the 4 hold downs that release at T0. As you can see on your screen, the strongback has retracted away from Falcon 9. The strongback is hinged at the launch mount and is going to rotate a few degrees away from Falcon 9. At liftoff, the strongback will rotate further away to clear way for Falcon 9. We should expect Stage 1 LOX load to complete in just a few seconds. This first stage is fully loaded around T-minus 3 minutes, with the second stage finishing about a minute later. And now Stage 1 has completed loading. At this stage in the countdown, the rocket is nearly fully loaded with about 1 million pounds of propellant. That includes Rocket Propellant 1, or RP1, a highly refined kerosene, and liquid oxygen, or LOX, chilled to roughly 300 degrees Fahrenheit below zero. Looking ahead in the count, at T-minus 60 seconds, Falcon 9 will enter startup. At that point, the rocket's onboard flight computers will take over. From there on out, the countdown is fully autonomous. Just inside of T-minus 2 seconds, the 9 Merlin 1D engines will ignite, and once they're at full power, Falcon 9 will lift off from the pad and begin its climb to orbit. At T-minus 2 minutes and 8 seconds, the range is green, the payload remains healthy, and the team is still tracking no issues. Stage 2 LOX loading should finish up just inside the T-minus 2 minute mark. We just received confirmation that Stage 2 LOX load has completed. Falcon 9 is now fully loaded with 1 million pounds of RP1 and LOX. Coming up shortly, we can expect the gas closeouts to begin. Ground gas closeouts have started. That refers to venting and closing out gaseous systems, such as topping off tanks and sealing vents to maintain pressure. Coming up in just a few seconds, Falcon 9 will enter startup. You can see on your screen some of that gas being vented now.
Startup.
Falcon 9 has entered startup. At this point, the autonomous flight computers have taken over the launch countdown, and both stages are pressurizing for launch. We're now just waiting for the final go, no-go from the launch director.
Launch director, go for launch.
We have received a go for launch from the launch director. Let's sit back and watch as Falcon 9 takes NROL-172 to space.
T-minus 30 seconds. T-minus 15 seconds. T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, ignition. And liftoff of the Falcon 9. Go SpaceX, go NROL-172.
Vehicle is pitching downrange.
M1D chamber pressures are nominal.
At T plus 30 seconds and counting, Falcon 9 has successfully lifted off from Space Launch Complex 4 East at Vandenberg Space Force Base. We're now throttling down the engines to prepare for max Q, the point of maximum aerodynamic pressure during ascent.
Power and telemetry nominal.
Max Q occurs when the combination of speed and air pressure put the greatest stress on the vehicle. That should be coming up in just about 10 seconds.
Falcon 9 is supersonic. Max Q.
And there's that call out for max Q. Coming up next are several major events in quick succession: main engine cutoff, stage separation, second engine start, and fairing separation. Main engine cutoff, or MECO, is when all 9 engines on the first stage shut down. This is
I'm
followed
back,
by
chill.
stage separation, where the first and second stages are pushed apart. A few seconds later, the second stage engine will ignite to continue pushing towards orbit. This is known as Second Engine Start 1, or SES-1. Shortly after, the 2 fairing halves will separate and fall away, exposing the payload to space. We should begin hearing the first of these callouts in just about 1 minute. We are now just a few seconds away from the beginning of those events. As a reminder, that will be MECO, Stage Sep, and SES-1.
MECO.
Stage separation confirmed.
I'm back, startup.
And confirmation for that series of events, which again were MECO, Stage Separation, and SES-1, or MVAC. Start. Coming up next will be fairing separation. Once the vehicle reaches the vacuum of space, the payload fairings are no longer necessary and will be jettisoned and retrieved. As a
Fairing
reminder,
separation confirmed.
there's the call out for fairing separation. As a reminder, we will not be showing any views of Stage 2 today. If you're just joining us, you're watching live coverage of the NROL-172 mission. We had an on-time liftoff at 7:13 p.m. Pacific Time from Space Launch Complex 4 East at Vandenberg Space Force Base. In order to make its way back to Earth today,
All vehicles are following nominal trajectories.
we just heard a good call out there for all vehicles. In order to make its way back to Earth today, the Falcon 9 first stage has 2 more burns to execute. Next up is the entry burn, which helps to slow the stage down as it re-enters the upper part of the Earth's atmosphere. Following the entry burn, shortly thereafter, the booster will initiate the landing burn, which will slow the vehicle down before landing on our drone ship. You should hear the call out for that entry burn just about 2 minutes from now. During the entry burn, Falcon 9 is decelerating by firing its Merlin engines in the direction that it's moving. This causes it to fly through the engine's exhaust gases, which deposit a layer of soot on the vehicle's surface. This gives our flight-proven vehicles their characteristic look. That soot comes from the carbon-based fuel that Falcon 9 uses, and with each flight, the soot builds up a little more on the outside of the vehicle. We are just over a minute and a half away from the beginning of the entry burn. As you can see on your screen, Falcon 9 is equipped with 4 hypersonic grid fins, which are positioned near the top of the first stage and used for steering as it returns to Earth. These are the primary aerodynamic control surfaces for the first stage during atmospheric re-entry and descent. Grid fins are a critical part of Falcon 9's reusability system. You may also be seeing white puffs on screen. These are part of the Falcon 9's cold gas thruster system, which helps to orient it while in the vacuum of space. Reusability is key to lowering the cost of spaceflight, enabling more investments in
All
critical...
vehicles continue to follow nominal trajectories.
Great confirmation that the vehicles remain healthy. The Falcon 9 first stage that is supporting today's mission is performing this entry burn for the 9th time. Again, that's coming up in just about 20 seconds. You should see the graphics light up as the engines do on the bottom of your screen.
Stage 1 FTS is safe.
Stage 1 entry burn startup.
There's the call out for entry burn startup on the Falcon 9 first stage. This burn is set to last about 30 seconds and is slowing the vehicle down in preparation for its final burn and landing.
Stage 1 entry burn shutdown.
We just heard the call out for entry burns to shutdown, signifying the completion of the Falcon 9 first stage entry burn. Coming up next, will be the first stage landing burn in just a few seconds. The landing burn is the final burn of the Falcon 9 booster used to reduce the remaining speed of the vehicle for a precise landing on our drone ship in this case. You can now see the grid fins maneuvering the vehicle as it positions itself for that landing.
Stage 2 FTS is safe.
Stage 1 is transonic.
The landing burn is going to start in just about 20 seconds.
Stage 2 is in terminal guidance.
Stage 1 landing burn.
And there's that call out. That means that we are in the final burn for this booster before landing.
Landing leg deploy. Stage 1 landing confirmed.
And another successful landing of our Falcon 9 rocket. As mentioned at the top of the program, we will not be showing any Stage 2 or deployment views today at the request of our customer. So with the successful recovery of that first stage, we'll be bringing our live mission coverage to a close. We'd like to thank the National Reconnaissance Office for entrusting us with today's mission, as well as the Range and FAA for their support. If you're interested in more launch coverage, head over to spacex.com/launches for the most up-to-date information. While you're there, check out our departure board with all the details about our upcoming missions. And of course, remember to follow @SpaceX on X for more updates. Thanks for joining, and we'll see you again soon.